Deephaven community team, December week 2, with another demo for you. So first we have Jake showing off an Rss Feed Analyzer. So here we go.
All right.
Go ahead, Jake.
Hello, everyone. So, as Bender just said, I worked on an RSS feed sentiment analyzer. So what this app does is it pulls data from a few RSS feeds, performs sentiment analysis on the data in the feed, stores it in Deephaven to allow for further cool stuff to happen. So let's start by looking at some of the raw data. So this is the feed reading from Hacker News. So it's performing sentiment analysis using the default Python NLTK package. So we get a positive, neutral, and negative score and a compound for every sentence that we're looking at. And then we have another feed. It's pulling in the same data, but it's using a custom sentiment analyzer based on data from NLTK movie reviews. And that's just saying, positive or negative scores, a binary value. And then we have the same thing, just instead of looking at Hacker News, we're looking at one of the subreddits, Wall Street Bets. So, same thing, scores for the built-in analyzer and positive, negative for the custom analyzer. So let's see how this works. So the bulk of this app runs in this read RSS function, which is basically a parameterized method that continually loops, pulls from an RSS feed. If there's new data to pull in, it puts it in the Deephaven table. Otherwise, it just kind of hangs around for a little bit. So a couple of a couple of things to look at. We have the feed URL, we have the attributes we're looking at. We have a method that performs the classification. We have our Deephaven table writer, and then we have a way to convert or to extract the date time of the entry. So what this basically does, like I said, it's just a while true loop, pull from the feed. If there's not new data to look, or if there's new data to look at, continue. Otherwise, just break out of the loop. Then look through the attributes, analyze the attributes, extract the date time, and then write it into a table. So that's kind of all high level. So what's the actual meat of what's going on in here? So let's go backwards. Let's look at the date time converter first. So RSS feeds are kind of a standard, but there's not always a guarantee that everything is going to be the same. So I just decided to write, hey, a simple function that takes an entry and extracts the date from it and then converts it to a Deephaven datetime object. So for Reddit, just looking at the updated attribute. For Hacker News, it's looking at the published. So pretty straightforward. So now let's look at our classifier. So like I said before, we have two classifiers running. We are having one using the default NLTK package, and we have one using a custom analyzer that was trained. So this file is using the default classifier, and you can just see that right here. It's just this function. It takes a classifier, and then it returns a function that takes a string and performs the sentiment analysis on it. So this data right here is actually what's converted into a row in the Deephaven table. So if we go back to our UI, we can see our values right here. And then, same thing for the custom function. So same thing, we have this building this function based on the classifier, return a function that takes a string, and right here we just have the string and the result from the classifier. So that's how we end up with these values. So to go back to our read RSS function, attributes in the feed URL, those are pretty straightforward. Thankfully we had the same attribute in both the Hacker News and the Reddit RSS feeds, so we just looked at the title. But if we had a different name, maybe it was a capital T, we could just change that. And then we just kind of go down here. We have our RSS feed URLs. We make our table writer, get our table so that it displays in the UI. And then we just start a thread with the read RSS function. So we've got that right here. And then we just pass in our arguments through here. And you can see at the end, because this one's using the Reddit RSS feed, we use this Reddit datetime converter. Then if you look at the bottom, we have the Hacker News. The same exact thing, except right here we have the Hacker News converter. So that's how we get these tables in here. So once we have the tables in here, we can do a couple things with them. we can do some aggregations. So if we wanted to say, hey, what's the average, median, and deviations of our values? So we can use an aggregation to do that. So this is the medians of every value. This is the average of every value. And then this is the standard deviation of every value. And then just a couple more things we can do. We can, look at some ratios, some percent. So how many values in our table are strictly positive? So, we can compute that pretty easily. And then we can do a comparison of the custom analyzer versus the default analyzer. So that one said about 20% of posts had a positive sentiment, when this one says about 95%. So bit of a variation there. And then lastly, if we wanted to look at the tables together, we can join on our date, time, and the sentence, since those are going to be similar across, or unique across the tables. So we can make another table, and now we can see both of our analyzers side by side. Yep. Any questions?
Looks pretty cool. All right, next up we have Amanda showing a crypto and Twitter demo here.
Okay. I'm going to try and keep it really quick, and want to just remind you guys that this is a work in progress. So what I'm doing is I'm using an API through FinHub to pull in a whole bunch of crypto data. And so it's different exchanges, and I reduce the amount of data by a search term. In this case, you can see I have only Doge coins available. So lots of different Doji coins. The data is open, high, low, close, and it has timestamp and volume. So that's one platform. Now, based on my search term, I also have it going to Twitter and pulling some of the most recent tweets that have that same term, in this case, Doge. And much like Jake's, I do sentiment analysis on those, whether it's positive, negative, or neutral. And this was all done with Doge. And the cool thing is that if you change that search term, then hopefully I haven't reached my rate limit, but everything else changes based on that. So you get a whole new set of coins and data and everything else. So now it's on Ethereum. Lots of zeros for Ethereum. And then the same thing for the Twitter. It pulls that same search term, and now we'll tweet the new data. Seems like it might. Maybe it didn't apply. No, there's something there in there. Okay. And it's updating in real time until you hit your rate limit, or limit your tweet so you don't hit that rate limit.
All right, very cool. All right, next up we've got me showing off a standalone React app I did. So let me just show my screen here so that everyone else can see. So what I did, so this is just a standalone React app I did. All it does is connect to our Deephaven community server and create a timetable. And so this table is just ticking away and then displays it in an iris grid. So this is a good example for others that want to use just our UI, but maybe not in the whole dashboard. They just want to show just a table. And so this is an example showing creating a table and then opening it. But you can also add query parameters. So this is just on the server here. But if I add query parameter, then I can load a table that already exists on my server in app mode. So in this case, I'm just loading the Miami table that is already on my server in app mode. And it's just a basic table without the dashboard and everything else. So those examples will be posted in the examples repo soon. All right, and that's it for me. All right, and next up we have Jiangfeng and Colin.
So last week I talked a little about running the server using Jetty instead of Netty. Jianfeng and I have collaborated this week to make sure that we know what it's going to take to get that to run easily on Python, no matter what your setup is. So this week we have a brief demo where we're going to start with a machine that has Python installed, but not much else, and we're going to make a virtual environment. This lets us have our own settings for Python, specifically our own wheels. So we can say, here are the packages I'm interested in. We have a couple of wheels we have to have. So first we'll set up the virtual environment. I don't think we have that yet. And when you create a virtual environment, it makes its own directory. It puts its own artifacts in there, its own binaries that you can call. One of those is activate. You have to actually turn it on before it's ready to use, of course. That way you can switch between them when you're ready. We've got 2 wheels we have to install for Deephaven to work. One is JPY. That way Deephaven itself is able to talk to Python. One other piece I neglected to mention, you have to make sure your Python install has a shared library available so that we can call into it and have it do things. Apparently some of the default installs are all statically linked these days. So JPY lets us call into it, and then the next piece is the Deephaven wheel, which is the bindings from Python so that you can call it, you can call our table APIs and things like that. So that is finishing installing now. And now that this is installed, if we grab a distribution, this is not available yet to us, but the next release will have it. It's this start zip. That'll be renamed also. So once you grab one of these, you can just fire up the start script here, and that will start on your own machine without Docker, using whatever your platform is, whatever your Java, whatever your Python is, an instance of Deephaven. And then in about 10 seconds, it'll be possible to start up the browser and navigate to localhost 10,000, where we'll be able to see the environment that we just set up. All right, and so we can first of all confirm that Deephaven works here. We can make a new timetable. Well, first we got to import timetable, I guess. So this validates that not only did we start correctly, JPY is working, the Deephaven wheel is working, but Deephaven itself is working without any of the usual pieces we have. And then to demonstrate that this is really just an extension of what you already have in your Python console or Python IDE, on the other screen, Jenfeng is going to install another wheel, something like PyArrow. So PyArrow we could use to say, hey, here's a CSV over here, or any other wheels that we had in our earlier demos. Okay, this is a second terminal we have to activate here too to say we're in the same virtual environment. So just to double check it, we can fire it up quickly, make sure that PyArrow, I think we want PyArrow CSV. All right. I am not as well versed in Python. I should let Jenfeng drive and not try to suggest that I know what's going on.
So basically here, using PyArrow to read a CSV into a PyArrow table and can print it out after I convert it to a pandas data frame. Okay, so how do I share this one? Can you guys see my browser? Okay.
That works.
So I'll repeat the same thing in the browser. And, import the CSV. All right, and to CSV data demo.csv. Ooh, what is this? That's the autocomplete. We can do the same thing here. PAT.2 pandas. All right, so the same environment that you can access from either terminal or our web UI.
So next steps here involve getting the wheels we have, first of all, built for all platforms. We had to do some work to get them just on Macs to work. Up until now, we've only cared about Linux. We also have to make sure it builds on other versions of Python. I have tested it with 3.9, and it does build correctly, but we're going to make sure that we run the spectrum of other possible platforms and configurations that we need to support.
All right.
So this should also make a lot of those demos a lot simpler to say, here's how you just install another wheel. You just install it. You don't have to mess around with Docker.
All right. Very cool. All I think next up we have Devin showing, speaking of Docker, showing the Docker service view in IntelliJ.
Yeah. Let me share my screen here. On Windows and Mac, you guys have access to the Docker desktop, which presents a nice UI for Docker. We don't have that on Linux, but actually today I learned about the view from IntelliJ, and I just want to show that off real quickly. Let me share my screen here. Can you guys see this?
Yep.
So I just wanted to let everybody know that there is a Docker service view in IntelliJ. So if you're a developer and you want to explore all the different services that you've got running, you can hook up IntelliJ to look for Docker. So we can see we've got a core compose running right here with Envoy, gRPC proxy, and web. All of these have access to the logs, which is pretty useful. We can go ahead and scroll down through here just like a normal terminal. You can go look at the container properties, the environment variables. gRPC doesn't have any ports, but Envoy has some ports bound, so you could look at the ports, volumes, and then one of my favorite things that I just learned today, and there's probably more that I'm going to find that I like, is that you can jump right into a terminal here and execute commands. So you can create a terminal here, and I'm actually in the container now without having to actually type any Docker commands. So I can look at what Java processes I have running. I can look at the stack traces for my process and stuff like that. So there's a lot you can do and a lot of cool stuff that this interface presents, and I'm happy if other people find it useful too. The next thing I'm going to talk about is extended images. So we've recently revamped our build process to not only provide the Deephaven Python server with its normal set of requirements, Python requirements, but also we've got a suite of other ones that we will be publishing next month. The Natural Language Toolkit, which I think JJ showed off earlier, PyTorch, scikit-learn, and TensorFlow. And these are basically just extra requirements that we install against our base image. I wanted to go over how to actually view and walk through an image here. This is a tool that I'm using called Waggoodman Dive. It's a Docker image viewer tool, and it allows you to step through the layers of an image, a Docker image. And so this is the PyTorch image. And just to go briefly through it, we've basically revamped our build process. So instead of having to create about 2 gigabytes of disk space yourself when you're building this up, everything above this layer that I'm at right now is handled by an external build process. If we go through the layers just very quickly, so this is our base OS layer based off of Debian and Buster. We go ahead and install Java here. Then we install some basic requirements for health checks later on. Then we install Python. Then we install some server requirements. Then we install PyTorch here, and you can see this is by far the biggest layer at almost 2 gigabytes. And then very lastly, our Deephaven core build process, the only thing it does is it attaches on this final layer that's about 100 megabytes right here, which includes our wheels and our application and stuff like that. So it's kind of behind the scenes look, but it's much more streamlined now. It's kind of it's fun to navigate, and you can kind of see how these things are put together. And actually, this reminds me, I want to jump back to the Docker service view here real quick. To go over one more thing that is useful that I didn't go over. You can actually jump into the files here, the file view directly, and you can open it up in IntelliJ, which is really useful. So I can open up a file from a Docker image and bring it into IntelliJ, and that just makes it really easy to examine what's going on. So I can do the same thing here with Envoy. If we go to files, we can go ahead and look at its entry point and stuff like that. So I just found that really cool and useful. Hopefully other people will too.
Mm-hmm. All right, very cool. Well, that's all we've got for this week. We'll see you again soon. Bye.
Deephaven. That was super useful. Do you think you would be able to do a demo on that with like 4 minutes and we could put that on YouTube? That